Donations to the Python Software Foundation are entirely tax deductible, so get on that button. Right, next we have James Bennett, who enjoys telling us about falsehoods that programmers believe about usernames and also several other things. So please make him feel welcome on the North Bay Python stage.
So hi, my name is James, like it says on the slide. That's also my Twitter handle. I will be posting the slides there later if you want them. And once upon a time, I did something silly. I wrote a user registration library that people could use with Django. And it was silly because I thought it was going to be easy. I mean, user accounts, how hard can those be, right? Well, of course, it turns out it's really, really complicated. And today, in the spirit of open source, I want to share that complication with all of you. Aren't I nice? Or at least one little slice of it, which has to do with how we identify users. Now, I do want to lay out a couple expectations. If you read programming forums, you may have seen a certain type of article that goes around. It's the falsehoods programmers believe about something. So there's, falsehoods programmers believe about addresses, and falsehoods programmers believe about dates and times. And maybe this talk could have been falsehoods programmers believe about usernames. Could have been. But it isn't going to be. Because I really don't like those articles. The usual format, if you've never seen one, is this big, long list of things, and it just says, these are wrong, don't do them. But it doesn't tell you why those things are wrong, and it doesn't tell you what you could do better. And that's what I want to try to do today. I want to explain not just that this is complex, but why it's complex, and give you some tips for how to manage the complexity. Now, you may be like me. You may be thinking, well, how hard could this really be? Especially because I'm about to spend 10 minutes telling you how to compare two strings to check if they're equal. And you might be thinking, well, we have an equality operator in Python. How hard can it be? And does it really matter that much? Well, yeah, it turns out it does matter. As programmers, we have a responsibility to get this stuff right, because if we don't, it can hurt real people. So let's see what we can do about getting it right. Also, there's an election in 2 days. If you can, please vote. So, let's talk about identifiers. Identifiers should be easy, right? We all have a database. It can auto-generate IDs internally. We know how that's going to go. It's perfectly easy. We can just use those, right? That's a real US Social Security number. It was the Social Security number of Hilda Witcher. And if you've never heard this story, it's pretty good. Hilda was a secretary. She worked for a man named Douglas Patterson. And he was an executive at the E.H. Ferry Company, which made wallets. And in 1938, when Social Security was new and exciting, they decided, we're going to show off how easily you can carry a Social Security card in one of our wallets. So every wallet came with a replica card with a number on it. That number. The Social Security Administration estimates that around 40,000 people tried to use that number as their own. Some were still trying it as late as 1977. Hilda had to get a new Social Security number. This is the sort of thing that if you read web application security guides, they'll call it an insecure direct object reference. It says anytime you expose an internal identifier and somebody else picks it up and says, I wonder what happens if I plug that in over here. And this routinely makes top 10 lists of security vulnerabilities in web applications. And yet lots of sites still do this. They use an internal ID as just their public identifier for a user. And even if it's not a Social Security number, even if it's not as sensitive as that, even just things like finding out how many users there are or who they are, scanning that entire range, can be a problem. Even if you lock down the access, make sure nobody can plug in a user ID where you weren't expecting it, make sure nobody can just scan that whole range of things, there's still information people can get out of this. And I'm going to suggest, if you want a fun read, go to Wikipedia, type in German tank problem. This was something that came up in World War II. Allied intelligence wanted to know how many tanks the Germans could make. Except they didn't know. They got a surprisingly accurate estimate just from doing statistics with the serial numbers of the ones they'd captured. That was enough to get them to within about 10 per month error on their estimates of production. You can find out surprising things from very little data that you've exposed. So let's maybe not use internal identifiers. So what else could we do? Maybe email. Everybody has an email address, right? Email's easy. I notice nobody's nodding their head to agree with me. Well, that's good, because email actually isn't easy. Have you ever looked at what you can legally do in an email address? By the way, that's from a wonderful thread that's just a list of things that are technically legal to do in email addresses. If you've ever tried to validate an email address, maybe you thought, I know, I'll use a regular expression, as the saying goes. Now you have two problems. You can actually do this. There is a regular expression that will validate an email address. It looks like that. This is from a Perl module called RFC822. It's named after the standard for email addresses. And the author is a guy named Paul Warren, and he says, quote, "The grammar described in RFC822 is surprisingly complex. Implementing validation with regular expressions somewhat pushes the limits of what it is sensible to do with regular expressions." And if a Perl guy is telling you maybe regular expressions aren't the right tool for the job, you should listen. Now, there are simpler ways to validate an email address. How many of you are familiar with the new form input type equals email from HTML5? The HTML5 spec provides validation rules for that. And you can just copy what they do. They provide a regular expression. And I love the way they describe this. It's in, if you want to go look it up, section 4.10.5.1.5 of the HTML5 standard, where they admit that it is a willful violation of the email specs, because it doesn't allow everything you can technically do in an email address. But they go on to say that the specs for email are, quote, "simultaneously too strict, too vague, and too lax to be of practical use." So if it's good enough for the major browser vendors to violate the spec, you should feel free. Don't worry about it. But this means email, maybe not the best thing. Also, massive privacy issue if you start using email addresses as public identifiers. So I guess we're probably stuck with usernames, or something like it, some kind of unique string. Unfortunately, there's nothing hard whatsoever about unique strings, is there? So let's say we have a startup. We're going to do a startup. We're going to fire up a database. We're going to fire up Postgres. We're going to make an accounts table. We're going to put a primary key, unique username, password, and an email address. Boom, we're done. Ship it. Let's take a nap. Everything's good, right? Well, so here's a question. How many usernames, distinct usernames, are in that list? A lot of users have been conditioned, especially by email providers who also willfully violate specs, have been conditioned to believe that their credentials are not case sensitive. And even if they are, there's a bigger problem than user confusion. What happens if you sign up as that first username, and I sign up as the second one? Can I impersonate you? Could I convince your friends and your family that I'm you? Could I get personal information about you from them? Could I convince customer service at the site that I'm you? Get access to your account? These are real things that will really happen. If you run a site that has user accounts, you will have to deal with people who want to stalk, who want to harass, who want to go after people, and they will use tactics like this. One of the ways you can protect yourself is by avoiding this problem. Make your user identifiers case insensitive. That's easy, right? Let's go back to Postgres, change that column type. Now it's case insensitive. Ship it. Let's take another nap, because naps are awesome. Except case, it turns out, is not such a simple thing. Does anybody speak German? Yeah? Yeah, how's case in German for simplicity? Yeah. Anybody speak Dutch? Dutch has some fun times. Python was created by a Dutchman. Python's string methods don't get this right. So I have a degree in philosophy. I took some ancient Greek in college. Greek has some fun with casing. Then there's the Turkic languages. This is Turkish and Azerbaijani, where the dot or the absence of the dot over the I must be preserved because those are two different letters. So case is actually not that simple. If you go and read the Unicode standard on case, and you're welcome to, you will find out there are at least 3 different cases in Unicode and at least 3 different definitions of how to determine a character's case. In fact, case is reminiscent of certain other things in that it is not binary, it is not transitive, you cannot assume it from looking at a character or from looking at the character's name, and some characters might say, I don't have one. Some characters might say, I have multiples. There are, in fact, characters in Unicode that will answer yes to both are you lowercase and are you uppercase. So case is a little more complex than just doing a case-insensitive column in Postgres. But that's not the only problem. How many usernames are in this list? If you're not familiar with that name, I like baseball. I'm a big fan of the Chicago Cubs. Javier Baez is a player for them. He's a whole lot of fun to watch. But from the fact that I'm asking you, you probably can tell there's something going on here. If you asked Python whether these are the same string, it would tell you no. Because one of them uses a composed single character for that A with accent. The other one uses a separate A and then a combining accent mark. This is a thing that happens a lot in Unicode. There will be multiple ways to write the same thing. But this is actually even worse than the case sensitivity issue, because really, can you tell the difference between those two just by looking at them? So what are we going to do? Well, we open up our hymnals to Unicode Technical Report number 36, which I know you have all read and memorized. And it gives us a suggestion for what to do when we want to prepare 2 identifiers to be compared to each other. What it says to do is normalize to form NFKC and then casefold. Now, that's a fair bit of jargon. And if you're not a Unicode geek, you can be forgiven for not having any idea what that meant. If you want to know all the details of how normalization and the different normalization forms work, how casefolding works, feel free to come find me after this talk. I will talk your ear off about it because I am a grumpy old Unicode geek. But what you need to know is normalization is about dealing with this problem. Normalization takes 2 strings that write the same thing different ways and makes them be equal on the other side of the normalization. Case folding is similar, but for case. And I do want to mention Python's documentation I'm not a big fan of, because it says case folding is like a more aggressive form of lowercasing, which is not actually correct. As we learned a minute ago, case in Unicode is complex. A case-folded string may look lowercase if it's all characters from a European language, but there's no guarantee that it will look lowercase to you. A case-folded string is case-folded. It is not lowercased. So keep that in mind, and maybe one of these days I'll get around to submitting a pull request to Python to fix their documentation on it. Now, I do want to mention, email's not a great public identifier, but if you do end up collecting email addresses, it's worth considering something similar. How many email addresses are in this list? And the answer is, it depends. The specs say those are 3 different email addresses. A lot of email providers, including Google, say these are 3 different ways of writing the same email address. Now, you thought it was bad enough when I had a username that looked kind of like yours. Lots of people are trained to believe email addresses are not case sensitive and dots don't matter. In fact, there are tons of life hack, put dots in your Gmail address articles floating around out there that tell people to do this, which means the chance of somebody being fooled is even higher with email addresses. So if you're going to collect them, that's okay, as long as you're using them for the purposes of good and not evil. But probably you want to do some normalization on them. You want to treat them as case sensitive. You probably want to do some Unicode normalization. You probably want to ignore dots. Once again, this is a violation of the specs. But hey, it's good enough for HTML5. It's good enough for the browser vendors. It's good enough for Google. It's good enough for us, right? We will violate the email specs and we will power through. So that should be everything, right? We solved all the problems of usernames. We figured out how to do uniqueness. We figured out how to do Unicode normalization and case sensitivity. There can't be it. All right. You thought I was talking about security before. We have not begun to talk about security. So how many of you have seen this XKCD comic? It's called Exploits of a Mom. She's getting a phone call from her son's school because she's given him a name that causes a SQL injection attack. against the school's student database. Presumably, she also has a daughter whose name will cause a cross-site scripting attack when they show it on a web page. But this is an important reminder. Usernames are user input. And what is the first rule of user input? We don't trust user input ever. Because people will do things like that. Sometimes they'll do it just for fun, sometimes they will do it to do bad things to you. Now, fortunately, there is an easy solution here. Just use modern Python frameworks and libraries. All the popular database libraries know how to do parameterized queries. They'll prevent most SQL injection attacks for you. All the templating libraries know how to escape things and handle variables, so they'll prevent a lot of cross-site scripting attacks for you. You don't actually need to do much, because those libraries will take you, not 100% of the way, but I'd say 95 to 99% of the way. Just keep in mind, for those last few percent, that any username, and in fact any user input, is not to be trusted and should be treated as actively malicious until you have explicitly made it safe. Now, that's the easy security problem. How about this one? How many different usernames are in that list? And I'm not doing anything funny here with case. I'm not doing any funny combining characters. Those are both the same underscore. By the way, you probably want to learn about Unicode punctuation. But these strings are not equal, because one of them uses a Latin lowercase a, and the other one uses a Cyrillic lowercase a. And yet, you look at these, you can stare at them all day long and never notice a visual difference between them. This is what's known as a homograph attack, or a homoglyph attack. Most people, if they've heard of it in the context of domain names, where people would do things like register paypal.com, but with a Cyrillic A instead of a Latin one, and then see how many people they could convince to give up all their money. This is not as much of a problem outside the context of domain names, but it is still a problem, because this is really, really convincing when you look at it. So we should probably do something about it. What we're going to do is, once again, open up to Unicode Technical Report, this time number 39, which deals with security. And it gives us some useful definitions and some useful tactics we can use. It defines this as what's called a mixed script confusable. What that means is this string contains characters from multiple scripts. Some are Latin, one of them is Cyrillic, and some of them can be visually confused for other characters in Unicode. And yes, there is a database in the Unicode dataset of all the characters that potentially look like another character, including what they look like. There's also a script property that you can access to figure out if a string is mixed script. And now it's time for the bad news, which is that Python doesn't give you, in the standard library, enough access to the Unicode database to be able to do this. But the good news is somebody went out and wrote a third-party library that does it for you. It's called Confusable Homoglyphs, and it has this wonderfully named function, isDangerous. I like functions that are named this way. You throw a string in there, it returns true if the string is mixed script and contains visually confusable characters. Otherwise, it returns false. If you play around, that Confusables module does have some other functions in it that are kind of cool. They can do things like show you what are all the script properties, what are all the characters that could be visually confused, what could they be confused with. So if you want to have some fun learning your way around Unicode, you can play with that. One thing I want to note, this is not just a validation rule, this is a flat-out reject it. I suppose it's possible that someone could have good intentions and submit a mixed script confusable string to you, but it's very, very, very unlikely. It's probably safe to just reject that and deal with it manually if they contact you, because the odds of someone having good intentions versus having bad intentions, I'd say maybe like 99.9% bad intentions. Also, if you're going to use this to check email addresses, and you can, be sure to split the email address first. Split it into the local part and the domain, that's everything before the @ and everything after the @. Check them separately. because not everybody has control over what the domain of their email address is. But lots of people do get control over what the local part of their email address is. So, don't hold it against them that they have a domain that's a different script than the name they chose. So we're done, right? We've solved everything. Oh wait, no. There's another problem. How many of you have signed up for a site and it created a user profile for you? And a user profile may be based on your username, which shows up in the URL. Have you ever wondered what would happen if you signed up as a user like that? Maybe if you put in your user profile, our login page has moved. Please click here to continue logging in. How many people do you think you could fool into giving up their credentials if you did that? Does anybody think this attack would actually work in the real world? Have you ever heard of a site called Keybase? Keybase is a place where people can share their PGP keys so they can send and receive encrypted email. And they have a verification process where they give you a little snippet of verification code and they tell you put it in a file named keybase.txt and put it on your website. And that will prove that you own that website. You ever wonder what happens if you create a user named keybase.txt on a random website and fill in the verification snippet correctly? You end up as the verified owner, from Keybase's perspective, of that site. This was not the only site he was able to do that to, by the way. So, okay, user profiles may be a little dangerous. There are also a lot of sites and services that want to create an email address from a username. Could anything go wrong with that? Now, all due respect to them, because they're doing good things now. If you want a real-world example of someone getting bit by this, in 2008, someone got a certificate for one of Microsoft's websites because they signed up as SSL certificates at live.com. And it turns out SSL certificate vendors will treat certain email addresses as special. If you can send them email from those addresses, they treat it as proof that you own the domain. And this was not the only time that happened to Microsoft. It happened again in 2015. The second time it was someone was able to get, I think, hostmaster at live.com. And then, of course, there are a lot of sites and a lot of services that will create a subdomain for you from your username. Well, nobody can do anything malicious with a subdomain, can they? So all of these have a similar pattern, and all of these have the same solution. There are certain usernames you probably shouldn't let people have ever. What exactly you want to reserve, what you want to have in your list of reserved names is going to vary depending exactly on what you're doing and what you're doing with usernames. This is a wonderful blog post which goes into some detail about things that I haven't even covered, things I haven't even touched on, that usernames can do when they're used the wrong way, and some suggestions for a starter list of usernames that you should probably be reserving. My user registration library for Django now, I think, is reserving over 100 different names and probably should be doing more. I would advise you tomorrow when you get back into work, sit down, see if you are reserving any usernames, go over some of the threats that could be posed, and see if you can't come up with a list. Now, I could keep talking and talking and talking about this. In fact, I could go on for hours, because there are plenty of things about this topic that I haven't even gotten into yet. But as kind as the North Bay organizers are, they only gave me half an hour. So I do want to do one last thing. Instead of telling you things that are wrong, I want to tell you something I think is right. And as was foretold by prophecy on the slide, I am now going to say the phrase tripartite identity pattern, which is a bit of a mouthful. But almost all of the problems I've talked about today, almost all of the problems you run into with usernames, come from the fact that we overload a single identifier and make it do too many different things at once. So what if we just solve that? This is an article. You can find it by Googling the phrase tripartite identity pattern, or when I post these slides later on, you can find the link there and click it. It's written by some people who've been building socially oriented websites for far, far longer than I have, and they have some really hilarious stories, which I recommend you read. But they also came up with this, the tripartite identity pattern, where instead of one identifier, there are 3. One of them is an internal identifier, one of them is a login identifier, or a credential, and one of them is a public identifier. Each account gets one and only one unique internal identifier, and it never ever gets exposed publicly. That can be your database-generated value. Login identifiers and public identifiers, an account can have multiples of each, and they can change over time. And this is an incredibly flexible system that deals with a lot of the problems, avoids overloading a single identifier. There's just one problem with it, which is that I don't know of any good Python library out there that implements this. I don't know if any of the frameworks have this built into their auth tools. So, maybe one of you sitting here will think, well, how hard could that be? And one day, some years from now, you will be up here on this stage telling us exactly how hard it was, but having emerged with a useful piece of software that we will all thank you for. Now, I know I said lots of these things are hard, lots of these things are complex, but I do want to make the point. All of these problems are real threats to real people. And I want to reiterate, as programmers, it's our job to get these things right, protect our sites, protect our users, and ensure their safety. So hopefully there's something here you can take away. If you have questions, feel free to come find me afterwards. I'll talk your ear off about Unicode geekery. There's my Twitter again. Slides should be posted later this afternoon. And just in case you'd like to work somewhere where doing it right is a way of life, my employer is hiring. Feel free to come talk to me about that too. Thank all of you for coming, and I'd like to thank the North Bay organizers for having me here.
The North Bay Path